write computer programs. I have a bachelor's degree in music and a master's degree in computer science. It's always fun to program a computer to make music. The first time I did this was way back in the 1970s with core memory and a transistor radio and timing loops. It's a lot easier these days now that computers have music synthesizers built into them. Did you know that JavaScript allows you to access the synthesizer? There's a whole bunch of things you can do. You can play individual samples. You can emulate a mellotron. You can also emulate a Moog synthesizer or a Hammond organ. Here's a toy I wrote on my webpage, marklutton.com. It creates sound by additive synthesis, like a Hammond organ. Using the normal keyboard, you can hold a note for as long as you want. You play several notes. So here I am just playing on the keyboard. I like to use sound to diagnose problems. I call this technique diagnostic music. All you have to do is have the computer play sounds according to what your program is doing. I'll show you an example using JavaScript. There's a technique that web pages use, which is called Ajax, which stands for Asynchronous JavaScript and XML. Which is a little misleading because you don't have to use XML for the data. In modern JavaScript, you can use the fetch function for this, but most existing web pages still use the earlier method of creating an HTTP-request object, also called an XHR, and then using it to make a request to the web page and process the result. Now I'm going to show you how to make the browser play a musical note or chord every time a request is made. But first, I'll tell you a few things about JavaScript. As you know, just about everything in JavaScript is an object. An object is basically a hash map, and you can set new properties on the object anytime you want. The properties on the object are like the members of an object in a language like Java or C++, but they can be dynamically defined. They can be permanent values, they can be objects or functions. And instead of base classes, we have prototypes. Every object has a prototype object that defines the default properties. Let me show you about setting properties on an existing object. We press F12 to get a console. There's a function alert built in. Hello world. Alert hello world. There we go. It's just a function, right? But like all functions, it's a kind of an object. And like all objects, you can set properties. So let's say alert.foo equals 3. Now if we type alert.foo, there's a 3 we put there. We can say alert.foo. There's no real reason why you would want to set properties on alert. That's just the way the language was designed. I don't know why, but it gives you a zillion places you can hide things where nobody can find them. If I set a property on alert, would you ever think to look there? Where does the function alert live? Well, it is a property of the global object. The global object is called window. That alert is the same one. I can even prove it's the same one by saying alert equals window dot alert. True. Anytime you use a variable that you have not declared with var or let or const, it's defined on the global object. So if we, for instance, say xyzzy equals 17, that is window.xyzzy. Same object. If you're used to C++ or Java, JavaScript is somewhat different in the way it implements object orientation. JavaScript has inheritance, but is prototype-based inheritance, not class definition-based. Recently, JavaScript has added a class keyword so that you can define classes in a way that looks a lot like Java, but this is syntactic sugar, and the underlying prototype-based rules have not changed. Since the alert function is a property of the global object, you can actually redefine it. And let's try that now. Let's just give this a try here. let's say, first of all, we'll define old alert. Okay, now we've got a new property, old alert, which points to alert. They're the same function. And again, I can say old alert equals alert, because they're the same. Now I'm going to write a new function, new alert. This function takes a variable number of args, of which argument 0 is the message. And I'm going to say, I'm going to put something before the message in arg 0. So I'm going to say args sub 0 equals the big dummy says plus whatever it was before. And now I'm going to return, I'm going to call old args, old alert, passing it args. So this is our function wrapper. Now I'm going to say alert equals new alert. That is the switcheroo. So now alert points to our new function. So if I go back to alert hello world, the big dummy says hello world. If you're used to C++ or Java, JavaScript is somewhat different in the way it implements object orientation. JavaScript has inheritance, but it is prototype-based inheritance, not class definition-based. Recently, JavaScript has added a class keyword so that you can define classes in a way that looks a lot like Java, but this is syntactic sugar, and the underlying prototype-based rules have not changed. A Java or C++ object has methods, or member functions, and fields, or data members. So here we have a definition of a class, instrument, and a subclass, organ. The instrument is a more general instrument that can play musical notes, and the organ is a more specific instrument. This is not correct syntax for either language. This is just to show you what it might look like in Java or C++. Methods are defined in the class definition. In our organ class, we define a constructor and we override two methods. Everything about the class is frozen at compile time. An instance of organ contains all the data members initialized by the constructor. Now here's what it would look like in JavaScript. Again, not correct syntax, but a list of what's defined in the prototype. First of all, the properties do not have type specifications. And second of all, looking at the instance, where are attack time and decay time? Suppose we refer to attack time by saying let A equals our instance.attack time. We look in the instance, it's not there. We look in the prototype, it's not there. So we look in the prototype of the prototype. There it is. This allows JavaScript objects to be very lightweight, even if the class definition has many members. The object needs its own copy of a member only if the value is different from the prototype. We can add member data and functions to an object at runtime. Here we create a new organ, and we decide it needs a Leslie speaker. So we add members to save the state of the Leslie on or off, and turn it on or off. Now we also have to change the start note function, which is running while the note plays, so that it produces the effect of the Leslie. Now we can start playing. We can wait 1 second and then turn on the Leslie, and then after 5 seconds we can end the note. And here is our organ instance. It has the original waveform, and then it's got the instance data that we just added. We have our change start note, probably a wrapper function. We have our new Leslie on and set Leslie. Now, what if we decide after we've added a Leslie to this organ that we want every organ we create to automatically come with a Leslie speaker? Instead of adding to the instance, we add new data member and a new method to the organ prototype. And we also change the definition of start note. Now notice, we've created a new organ here. After we created the organ, we added our things to the prototype, and then we start using it. So how can how can it be that we created an organ without a Leslie speaker, and then by adding the definition of Leslie to the prototype, our organ has a Leslie speaker? Just because if it doesn't find something, it looks in the prototype. So to start with, we call start note. Now we've already overridden start note, so it'll call the new start note. Then when we set Leslie, at that point, it says this.Leslie on equals setting. It sets it true. This points to the instance. Even though this function is defined in the prototype, remember O.setLeslie as the context of the instance, so this is the instance. Now let's see how we can apply this. This is a typical kind of clickbaity web page. I mean, I like George Takei and he's got interesting stuff, but this page loads a lot of ads, does a lot of tracking, does a lot of stuff like that. His page makes use of XMLHttpRequest. And let's look back at the slide and see how he uses it. Now, what happens is for every request, the page creates a new XMLHttpRequest object. Then it calls open and send, which are methods of the prototype. So we're going to pull a switcheroo here. The first thing we do is define a new property on the prototype. Of course, there are lots of places you can hide stuff, and why not just hide it on the prototype of XMLHttpRequest? It's going to stick around. So we make a property old_open because we're going to make a wrapper. So we point old_open to the original version of open. Now we define the new function, and it will do some things such as saving the method and saving the URL, and then it is just going to call the old function. And then finally we switch out the old function and we switch in the new function. So from this point on, every time he creates a new XMLHttpRequest and calls open on it, it calls our wrapper before calling the original. Now we'll override send. Send is when the request is actually made. Now I've already put a synthesizer onto the prototype, so I can call this.synth.playNote. So I decide what I want the note to be. I pick a random node. Actually, what I do is I pick a node according to the URL. So going to a particular web address will have its own unique note. So we play the note and we call the old send. Now, playing the note, the actual playing is asynchronous. It happens inside the browser on a different thread. So this synth play note returns instantly, even though the note plays for a little bit of time. So now then we point the send to new send. Now let's go back to his page. Let's press F12 to get a console, and here's what I'm going to do. My paste buffer is full of all my code that is going to do the redefinition of both XHR, HTTPRequest, and fetch. So what I'm going to do is, first of all, I'm going to refresh the page, and then as quickly as I can, I'm going to dump in my own code. Wow. Listen to all that activity. Now, I want to point out, we're only listening to the Ajax request. There's a whole bunch of other gets that you can see scrolling by. Those are done by doing things like set location or running in an iframe. Every iframe has its own context, so our synthesizer is not in the iframes. It's only in the main frame. Well, let's see what's going on here. Let's make it scroll a little so it'll do more requests. Oops, there's a little thing here. Now, let's move the mouse around a little. Oh, it's getting a little excited. Oh. Again, a single node is an XMLHttpRequest. A chord is a fetch. He's using both functions. Notice how when you move the mouse around, it really goes wild. So he's tracking all your mouse movements. Why is he doing that? Well, I think the purpose of that is to determine whether you're human or a bot. It could be a bot that's just going around clicking on all the ads in order to add clicks. Wow. Different notes means it's going to different websites. Listen to all that activity. So this is how diagnostic music works. If you can translate information into musical terms that mean something to you, you can hear that information much faster than you can read it. Also in my code, I added a function to dump out the different sites we went to. So first I'm going to filter on HTTP requests, because that's the output of my function. And then I'm going to call my function, which is dump URLs. So let's take a look here. Well, there were 23 unique sites. Now, there's a whole bunch of other information I didn't capture, the query lines, but if I did that, there'd be like hundreds of them. Each query line would be a separate one. So let's see, some of them only went, okay, this is the XMLHttpRequest, that would be the single notes, and there's 30 to e.deployads.com, and 10 to 33across.com, and 43 requests were made to adtech.advertising.com. And then, using the fetch function, well, he made 178 calls to stats.rbi.ms. That's when I was moving the mouse a lot. If I do it again, instead of 178, it's 204. This gives you just a small idea of the power of diagnostic music. We have seen how we can use it not just for our own code, but for any code a web page wants to run in our browser.